All right, which one?
65.
Oh, cool. All right. Let me build my way up to that problem. Whoever's asking that. Yes. All right. I'm gonna do a progression of steadily more difficult looking problems. I don't want you to realize they're all basically the same problem. We did one like this already, but how would I solve this? How would I solve this?
Times 4?
Yeah. Multiply by 4, because the idea is I'm always undoing what's being done. Somebody took x and divided the damn thing by 4. So I'm going to multiply by 4 so it gets back to what the hell x was. Undo what was done. Multiply by 4, plop, x is 12. That's amazing. So what if it was this? Let's do this. 2x. Let's do it. So x over 4 plus 5 over 4 equals 2x plus 1 over 4. Now that looks more complicated, right? But notice how everything is being divided by 4. So what can I do to both sides to get rid of all those stupid 4s? The same thing we did here. Do you guys see that? Yeah, if I multiply everything by 4, let's get some options here, Jeff. If I multiply by 4, if I multiply this side by 4, I'm going to distribute. So I just wrote 4 next to everything. Is that cool? Multiply this side by 4, multiply this side by 4. That makes it legal. The balance is maintained. And then the really nice thing is, I always have people have a 20 here somehow, but that 4 dies, right? Let the 4s die. Let us die, please. And then, that wasn't morbid at all. And then, isn't that a much nicer looking? Hell yeah. Do you notice how when the bottoms are all the same already, to make the equation true, I have to have all the tops equal each other? Does that make sense? Maybe? Everything's being divided by 4. So how do I make the equation better right from the bat? Multiply by 4. That undoes all those stupid divisions. Let that make sense. I can multiply both sides of an equation by any damn thing I want to except 0. 4 would be a smart choice because it makes all the bottoms go away. Are there any fractions left now? Everybody gets really excited when I show you how to kill fractions, but why was I allowed to do this? It's an equation. It's got 2 sides to balance out. You can't kill poor little innocent fractions just sitting there. Fraction die! No, you can't do that. It's got to be in an equation. And now, how would I finish this? Finish it. You could. All right, let's do this. So if I subtract 5, I'll get x equals 2x minus 4. All right, so what's in the wrong place? The 2x. So how do I get that out of there? No. You're not trying to get x by itself. You're trying to get the numbers by themselves. So what do you want to get rid of? 2x. How do I cancel the 2x out? Subtract 2x. Why would division not work? Because 2x is not multiplying by 4. Right? 2x is being combined with 2x is positive. So I'm going to kill it by subtracting. But what's wrong with that? Is that done? Beautiful. The last thing you almost always have to do is divide. So now I can divide by -1. The negatives go away, so I get x is 4. Funkadelic. So the beautiful thing is, if you have an equation and there's something gross about your equation, almost always you can get rid of that gross thing. Because you can do stuff to both sides. So if you have fractions in an equation, you can multiply by the thing that's going to make them all go away. It's beautiful. So now we've built up to the question I was actually asked. The person asked is being very patient. It's like, okay. Any questions on this here? You gotta love that. If you have fractions in an equation, you're allowed to kill them. That is so awesome. Can't kill every fraction. Don't get too excited. And when they're in an equation, you got them. So the one that I was asked about is slightly different from the one we just did. Just slightly. Which one was it again? 65. Okay. So this one looks like this. Of course, they use t. Oh, 2/3, sorry, plus 1/4 t equals 2. First thing I'm going to do is, everything's a fraction except for this guy, but he sort of is a fraction because I can put him over 1. Why was the last problem we did, why was it relatively easy? Because all the bottoms were the same. They were all 4. Or all the bottoms here the same? No. What can I make them all become? 12. Now, I cannot, I don't write this. I'm seeing too many people do this. Just become 12. Just take it, just become 12, all right? Because I know it's got to be 12. Well, this is basically telling me that 3 equals 12, is what you're saying. And that's a cause for concern. I really want you to understand, 2 divided by 3 is the same thing as 4 divided by 6. If you try it in the calculator, you're going to get the same thing. You're going to get 0.66666. They're the same number, so they represent the same thing. So that's why if I ever see a 2/3 somewhere, I can replace it with a 4/6 if I want to, because they're the same number. So as long as I multiply top and bottom the same thing, it stays the same number. What would I multiply? What's the LCD going to be? 12. It's so easy when these have nothing in common, they need each other. Aw, I need you 3. So, what's this guy need? 4. See, what did I really just multiply by? What is 4 divided by 4? 1. And when I multiply by 1, I don't change the number. I am making it look different, but I'm not changing what the value of it is. What's this guy need? And this guy needs everything. He's only got a 1. He needs freaking 12. That's going to make the bottom 12. The biggest mistake is to forget the whole number and just leave it completely the same. It's not allowed to have that happen. So what do I have now? I got 8 over 12 plus 3/12 t equals 24 twelfths. And of course, 24 divided by 12 is 2. So effectively, I just made things look different. But now, what do I multiply both sides by? Because everything's being divided by 12. So I made it look like the problem we just did, because the problem we just did was relatively easy. All right, so if I multiply both sides by 12, die 12, die 12, die 12. I like to think my math is sort of like a Game of Thrones math. People dying and losing things and such. What's left here? 3t equals, and that looks a lot better. All right, how do I solve this? Subtract 8, I love it. Get the thing with the variable in it by itself first. So get rid of the other crap. Then that 8's in the wrong place. It's got to go with the other numbers. What is happening over there? That's the literal Game of Thrones over there. 16. And then divide by 3. Don't force it. It's just 16/3. 3 doesn't go into 16 evenly. If you wanted to, you could make it a mixed number. It didn't really say. Yes, sir.
So I asked for help on this one yesterday at the Math Lab Center, and they took me a completely different route that just took a whole lot more work, and I still got.
Did they multiply by 12 first?
They had me multiply the first fraction by 3, the other side by 3, and then they had me multiply the fraction next to t by 4.
But did you get to the same answer?
I did. It just took.
Okay, I like it. So, I'm not sure how to say this. A lot of the tutors have not worked with math as long as I have. And, so it's not their fault. I mean, they show you a way it works, but there's so many little things you pick up as you do math that this might not have occurred to them, right? And they show you a way that works. Do you see how the way they took you is similar to this way? Maybe it did the same thing, but just in a different order and stuff. Yeah. So there's a trillion different ways to do any problem. I'm always going to try to show you what I think is the most effective way. Okay, cool. And if I ever show a way and you think there's a better way, let me know. I mean, I am a teacher, but I am always a student, so I'm ready. Yes? Who had? Oh.
Yeah, could I just ask a quick chapter 1 question?
Yeah, of course. Did you have a question about this?
No, I have a question about 2.1.
Okay, so let's go. Which?
Okay, no, it's just like a general, like, what's the difference between simplifying and solving?
A solve is for an equation. Solve means you're going to get a number that makes the thing work. Simplify is when you don't have an equation. You just have an expression. So if I give you this, 4x plus 2x, I cannot ask you to solve that. There's no anything to tell you what x is. X could be anything. But I could ask you to simplify that, of course. What is 4x plus 2x? 6x. But if I said 4x plus 2x equals 12, now I'm going to ask you to solve it. You should be able to come up with a number that makes that work.
So you can't simplify an equation.
Well, to solve an equation involve, what would be the first step in solving this equation? Simplify this side.
Yeah.
So simplify is a part of the solving process. Yeah. Simplify is a little more easier, direct thing. It just means, most of the time it means combine like terms or distribute stuff. Just get stuff together. Solving equations involves that and then figuring out what x is. Yeah. I like it. You get to a point where, for some reason, if I had 6x plus 2 plus x, and I say simplify this, people set it equal to 0 and get an answer. I'm like, how do you know it's 0? Why is everything in the universe 0? That's so bleak. It's all 0. It's like, holy shit, get some coffee. Oh yeah. Don't freak out too much about that. I obviously own a lot of math shirts. This one will freak you the shit out. Well, we will eventually get to complex numbers. So I don't know if anything look familiar up here. Pi should look familiar. Anybody? An E? I don't know if anybody knows E.
Is that an imaginary?
I is the imaginary part. Imaginary is a unfortunate word. Are you guys cool with negative numbers?
Yeah.
They were called imaginary when they were first thought of. Because they were like, how can you have negative 2 apples? And now we understand that negatives have meaning. They have physical meaning. Maybe not negative 2 apples, but like, I owe you 2 apples. I'm hungry. I got 2 apples. Give me 2 apples tomorrow. Now I have negative 2 because I owe you 2 apples. You see what I'm saying? So imaginary numbers, unfortunately, that name stuck. When we get to imaginary numbers, I'm going to show you a really kick-ass video that shows you they have a physical meaning. They are not just purely bullshit we created. They have a physical meaning. It really blows your mind a little bit, but that's in the future. Sorry.
And
So, yeah.
E is represents.
So, real quick, side note. Do you know where pi came from? And don't tell me the oven. Do you know where pi came from? Anybody?
To try to divide the circle up.
All right. So if you take any size circle, this circle, I know the Earth is not a sphere, but still cut the Earth in half, a circle that large. If you take its circumference, which is all the way around, divided by its diameter, you always get the same number. And every civilization, sort of like the Egyptians and all these other Greeks, they all had their own approximations for this, and they were all equally freaked out. They're like, why the shit would that happen? This must be a number from the gods. So we gave it a special symbol, and that's actually where the circumference formula comes from. This is actually the definition of pi. We multiplied d up, and we went, hey, there's a formula. Right? And of course, some of you guys remember there's also 2 pi r, because the diameter is twice the radius. Does this sound at all familiar? I don't want to... We're not suddenly doing this right now. This is just a side note. Right? This is just a side note. E, I don't know. I'm not going to get too deep in it. It also comes from various little weird things. I'm not sure how much I want to talk. I'm not going to tell you more than that. It's a number that popped up at a few different places, and we're like, holy shit, let's give that a symbol, because it seems to be popping up all over the place.
I heard it's like a logarithm, and it's supposed to just represent a long number.
Well, pi represents, what is pi? 3.141596, blah, 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 never stop.
Right.
That's why we gave it a symbol, so we don't have to write all that. E, same idea. It didn't come out of this, but it came out of a couple different situations. We're like, holy shit, it's the same number. Let's give it as a letter. And then now it's like remarkably useful. So it is related to logarithms and all that kind of stuff. Yes? Okay. All right. Let's come back. Yeah, I guess I have to. If I wear it, I guess I should explain it. All right. Where did I leave off? Was there somebody else had a question? Yes.
Section 2.1, actually, to number 60.
Did I answer the other question earlier? Yes, thank God. Number 60?
Section 2.
Oh, good. This is the question I never really got back to. All right, this one? There is a process that people overuse that you actually don't need for this problem. But a lot of you guys know the process I'm talking about. What's it called? Cross multiplication. You do not need that for this problem. Why is x not by itself? Because it's being what? Divided by 3. What's the one thing I need to do to make x by itself? Multiply by 3. Get rid of the, so I just have to multiply both sides by 3. I can make it 3 over 1 if I want to, right? So I get, bam, x is what? 6 over 7. I love it. Now, let me show you you don't need cross multiplication for this problem because x is almost by itself. Why do extra shit? But let me show you how cross multiplication works and why it works. So let's do this problem again. Let's use cross multiplication. All right. I'm not going to start with cross multiplication. I'm going to do the steps that leads to the shortcut that we call cross multiplication. What is the LCD? Remember what I said about fractions and equations? If you make all the bottoms the same, you can multiply by it and kill it. This is no different. It's just that there's going to be a shortcut because there's only one fraction on each side. So there's going to be a shortcut we can make. What's this guy need? What's the LCD going to be? So he needs 3. And he needs 7. Cool. So then I get 6 over 21 equals 7x over 21. So can't I multiply by 21 then? And I know, every time I do this, I can just feel somebody out there going, why is he doing all this? You just have to multiply. No, I'm showing you why cross multiplication works. I'm not showing you the way to do all these problems, right? This is the reason behind the shortcut. So look, I get 6 equals 7x. So what's it look like happened? It looks like that 3 came up because it really kind of did. You see what I'm saying? And it looks like that 7 just came up. So the shortcut I can make is just take whatever that is and bring it up. And whatever that is, bring it up. Because that's what's going to happen. So that's why it works. It only works when you have fraction equals fraction. That's the only time it works. If you try to use it anywhere else, you can, but you got to be really clever because it doesn't quite work exactly the same way anywhere else. So then, of course, what's the last step here? Divide by 7, and you finally catch up with what we got before. So the only real time you need to use cross multiplication is if the variable is like on the bottom or something, or it's a little more complicated. Is that decent? It's decent, Jeff. All right. Okay. Anything else from homework? Yep.
I wonder if you could go over,
Did you have a follow-up on this, or?
Yes, number 66. Would that be the same process?
All right. Real quick, sorry. 66. I would say that the x, I only need one step to get the x by itself. When we saw a problem like this before, you could look at it as 2 steps. What do I need to get rid of so the x is by itself? Yeah, the 3/4. So I need to get rid of the 4, and it's being divided by 4. So I multiply by 4. And it's also being multiplied by 3, so I got to divide by 3. So remember, you can just multiply by the reciprocal, because that's always going to make this 1. Could you, let me see, x equals 3 into 18, 620.
That's what I got.
You could write that problem like this. Whoops, where's it? Okay. Right? So the problem was 3/4 x equals 18. So I can write it as 3x over 4 equals 18 over 1. And then I can cross multiply. So yes, there are always more than one way. There's always more than 28 ways to solve an equation. But if I have a variable with a fraction in front, so it's almost by itself, I'm going to multiply the reciprocal. That's the quickest way. That would still work. Right? If you cross multiply, you get 3x equals, what's 4 times 18?
72.
72. Divide by 3, and remarkably enough, you get 24. Same thing we just got. Okay, lock it. Yes. Oh, wait, I skipped somebody. Did you have a question?
Yeah, I was wondering if you could make 2.2.
2299? Oh, no. I want to let more people. I have a feeling some people just got that. Don't worry. That's one I want to let people try. If that's the only one you have trouble with, or one of the few, then you're doing really good. Whenever you have a problem I assign from where it says synthesis, you can almost read that as just saying bonus. Not meaning you don't have to do it, but meaning it's a little bit extra.
Okay.
All right. Yes?
Can I get help on 81 and 2.1?
Since you asked so nice. 81. Ooh, all right. The only reason they have a little calculator sitting next to theirs, they're saying you don't have to like line up the decimals and do it all by hand. How do I solve that? How do I get t by itself? So 81 looks like this. All right, this is the one with all those decimals in there. Where'd it go? 483.297 equals negative 794.053 plus t. So what's the one thing I have to do to get t by itself? Yeah, add. This is negative this, I add it. I do the opposite of it. I add 794.053 to both sides. And they're being nice. They're saying go ahead and use a calculator to do this. You don't have to do all that borrow and shit by hand.
On like the quiz, are we able to use a calculator?
So on the quiz, I normally don't let you use a calculator, but I'm not going to give you a problem like this. I'm not going to give you a busy work problem. On the test, there might be a part 1 and a part 2 where you can use a calculator and not use a calculator on the other part.
Does the calculator have to be the one that,
Not necessarily. That's the one I'm going to be using, though. So when I do stuff on the overhead or something, I'll be using a TI. The Casio graphing calculator is nice. You do need some kind of a graphing calculator. Yeah. Okay. Anything else from homework stuff? Yes.
Where exactly can we like rent the calculators or?
Yeah. Remember the
I mean, not rent them, but can we like
check them out from the library.
Yeah, check them out.
In the library, you can check them out.
Okay.
In the Math Study Center, you can use them while you're in there. As long as you bring your student ID, they'll let you borrow one. Is that cool?
Yes, and we are allowed to use the calculator during quizzes and exams. Some quizzes and exams, or
Yes.
some are exempt from the test or quiz. They're like.
You're allowed to use a calculator in certain parts of certain things. So I would be very clear as to when you can and can't use it.
Okay.
So like on a test, I figure test 1 is going to have a part 1 and a part 2. Where when you're done with part 1, you turn it in, and then you can take the calculator out and use it for part 2. When you can use a calculator, it doesn't mean you don't show work. It just means you can write what you're going to do like this. You would write this, and then you plug that in the calculator. Which is why I was letting you use one, yeah. Okay. Okay, all right, so let's keep going here. I think, let's get back in this green book. We pretty much just covered some of what I wanted to cover, which is awesome. Yeah, I love it. So let's just do this page. So let's go to page 4. Whoa, shit. Let's see, how do I, where are you? I must have brought it out here. Where are you? There you are.
I have one question. I know eventually we have to memorize some stuff. Is there anything that you recommend that we should memorize for our quizzes or tests come up, formulas, whatever, blah, blah? In the front of the, or the back of the book, there's some stuff, but I didn't know if, go ahead.
For this first quiz, there's really nothing to memorize.
All right.
When we start getting to stuff like the line equations and stuff, I'm going to be very clear about.
Area, the triangle, all that, blah, blah.
Yeah, that's not going to be till later,
All right.
the area stuff, but I will be really clear about what you need to know. And if there's something I'm going to let you use, I would either put it on the quiz or we make a formula sheet. But most of the stuff you're going to have to know. I don't like the word memorize because even students who are in my calculus 3, they're like, I hate math because you got to memorize everything. And I'm like, no. How big do you think my brain is? My brain is no bigger than anybody else's. I don't memorize everything. I see why it works. It makes sense. That's not memorization. That's just do what makes sense. So if you think you have to memorize everything, you are not starting well with math. You need to see why things work. Why does it make sense? And then it isn't memorization. It's just do what makes sense. Right? You don't go, man, I keep forgetting to not put my hand on that dang burner. No, it's like, that don't make sense. I'm not going to do it. I don't have to, I forgot. I'm like, oh shit, I forgot. It just makes sense. It's not memorization. Right? There's no way in hell that the math people have memorized everything. Oh my God. I would forget everything else. Right? I wouldn't be able to walk. I'd just be rolling around from negative B, pressure minus. I'm like, forgot how to use my legs. All right. Sorry. Little rant. I have a lot of rants. Here, just try to solve this. I'll give you a little... Oh, I love the reaction. Oh, God. Give you a little hint. I mean, what would you do first to get this going? Yeah, distribute. You always got to look for those distributions because that frees stuff up. I'm going to tell you ahead of time something weird is going to happen. Let it happen. Something weird will happen. Let me catch up to you guys a little bit here. So what do you do now? Get your x's together. How do you do that? How do you get rid of these 6x's? Subtract 6x. I love how students can admit how much they hate x, and then on this kind of problem, you're desperately trying to save x. You're like, I got you, x. No, they die. They die. What's left? What's left? No, 0, 0. All the x's died. What's left? 4 equals Negative 1. Now, you did not just discover that 4 is negative 1. When we solve an equation, if you solve an equation and get x equals 2, that means when x is 2, the equation works. So, same thing. When 4 is negative 1, this equation works. When is 4 equal to negative 1?
No.
Never. So, what's the answer? No solution. So, is there an answer to everything in life?
Yes.
This is not getting to religion, by the way. Sorry. But no, there ain't.
Solution is an answer.
There ain't a solution. All right, so my kid has a lemonade stand, right? Is there any way that she can make $18 billion in the next 2 minutes?
No.
No. Screw that. So if I set up the equation's going to have a way to tell me that ain't going to happen. Right? Or, so there are situations that are just impossible. They just are. And I'm not a downer. I'm not even a realist. It's just that's what the hell's going on. Right? All right, is everybody cool with this? I don't want to make this any more than math. Don't start taking this as a philosophy of how to live. So this is math's way of saying your equation was bogus to start with. And look at this. Look what we got here. 6x is a number, right? So what does this equation say? What number do I add 4 to so that I get the same thing if I subtracted 1 from it? Is there a number I can add 4 to it and they get the same result if I subtract 1 from it? Ain't no freaking way that's going to work. So this is math's only way to communicate with us. Hey, that equation you wrote was bullshit, right? So the answer, when you get something that's never true, the answer is no solution. There's no way you can make x save this equation. There's no value of x that will make this true. No solution.
So like an exam or like a a test or a quiz or a homework. So do you have to like write out the problem, or do you have to write no solution?
You do exactly this.
Solution, the answer.
You do exactly this. You solve it. You get to this point. You don't circle this shit. Don't circle 4 equals negative 1. You have to interpret what that means. Now, let's do another problem. What if the problem was this? 2x minus 1 equals, what are you going to say, Jeff? 2x plus 3 minus 4. Right? So let me just solve this with you. 2x minus 1 equals, what's 3 minus 4? Negative 1. How do I get rid of my x's? I would do what? Subtract 2x. So they all die. So what do I end up with? When is that true?
All the time.
Always. So what's the answer? All real numbers. Any value I pick for x is going to make it work. So if my x's disappear, they have no control over the equation. Either the equation is always shit, so no solution. No x is going to save it. Or the equation doesn't care what x is. It's always true. So that's why all values work. When is 2x minus 1 equal 2x minus 1? Only if x is 3? No. It works all the damn time. 2x minus 1 is 2x minus 1. It doesn't matter what x is, and that's why it disappeared. You're all right. You're all right. Oh, you got to stretch and really freak me out. So this would be all real numbers. Wow. So you can either have no solution, which very often they use this symbol. This symbol means empty set. It's like, what are the set of the answers? It's empty. So that's, you don't have to make this symbol if you don't want to, but if you've seen it before, that's what it means. It means the empty set. Give me the set of all the answers. It's empty. Oh, there are no answers. Oh, shit. Or there's one answer, like the problems you were doing earlier. This would have one answer, right? T equals one number to make it work. Or there's infinitely many solutions. All the frickin' numbers work. Sometimes we'll use this symbol. This symbol, it means all real numbers. To do this by hand, you would do an R with an extra spine. Right? An R with an extra line next to it. That's how we represent all real numbers. Or you could just say all real numbers. I'll take either way, right? This is just shorthand for that. And you're like, God, math people are lazy. Just write the damn words. I agree. So you guys try these three. Try these three right here. real quick, just to help you a little bit on the first one, the easiest mistake to make is that negative has got to go through, right? It distributes just like anything. What's understood to be out here? 1. So you got to take the negative 1 through. Both signs should change. Alright, so the first one, is this cool? Some of you guys could maybe even stop right there and realize, well, x minus 5 is always x minus 5. So, but if I do want to go one more step, subtract x, I get negative 5 equals negative 5. That's always true. So what's the answer? All real numbers. You can either say all real numbers, or you can say all reals like that. So all real numbers, because it leads me to a statement that's always true, independent of what I make x.
What happened to the 2x?
What's 2x minus x?
1x.
Yeah. So 2x minus x is x.
Okay.
Cool.
Can you show us like a complication of real numbers? Like a real complicated, like, equation that the people will.
I want this to make sense. This idea is going to be forever. So we're going to learn more and more and more complicated stuff with equations. All that really matters is you do stuff, you get your stuff together, you undo shit, you get stuff together, you move your x, you move it, and if you get to this point, it's all real numbers. It doesn't matter how it started. Does that make sense? So, yeah, I can make, yes. Short answer is, yeah, I could. I can give you this ugly-ass equation. We're going to do a lot of millions of things. But this idea doesn't change. Right? If you get to the point where 6 equals 6, it's all real numbers. That's the answer. Yeah?
So the 2x, you don't multiply like by 5 is negative, is it? That's right.
Yeah, because the operation between the 2x and the x plus 5 is subtraction, not multiplication. It's not foiling. It's not a coefficient of it. It's 2x minus stuff. So that 2 is only on that x. There's no reason for it to distribute. There's no multiplication between the two things.
So the negative wasn't there would be more.
Yeah, the negative is in front of it, so it distributes. Yes. Yeah.
So I got x equals x, so what's better? To
Oh, I
have it-
see. You're good. So you added 5 to both
Yeah.
sides. You
So-
get x equals x.
So you want numbers or you want the x?
It's best to work all the way down to where the variables disappear.
Okay, got it.
So in your case, you could subtract x and you get 0 equals 0.
Right,
And so there you got numbers, and now you can say it's all real numbers.
got it.
Just because there are weird situations, it's best to go to the point where the variables are gone. Because people will make a mistake. I don't know if I want to. But you're doing it, Jeff. Yeah, that's true. So if I have 7x equals 6x, the answer is not all real numbers.
Right.
Because I can get my x's together, and I get x equals 0. The answer is just one number, 0. Do you see what I'm saying? So it kind of leads to that kind of mistake. So that's why I'm like, make sure you get all your x's together. That's the most important thing. Yeah. Cool. So what about this next one? You guys got this one? Let's see. What do you get here?
4x.
Plus 8. The negative 2 goes through. Minus 4x. Careful. And then minus 6 is negative 2 times 3. Minus 6.
Minus 3.
So negative 2 times 3 is negative 6. Is that cool?
Why is it in the negative?
All right, you ready? Let me see. Bring back that here, Jeff. All right. So right here, let me just pull this down by itself. Right? And actually, let me just go ahead and do this. Cool? Now watch. And you'll, yeah, you rewrote it, Jeff. Good job. I can rewrite this minus as plus a negative. Right? So it is negative 2. It is negative 2. Yeah.
But then you have a positive 3. But
Yeah. Negative 2 times 3 is negative 6.
oh, so it doesn't matter if it's the bigger number or because I was taught.
Oh, no. When you add or subtract, it's all about who's
yeah.
bigger and all that kind of stuff. Right? When you multiply, the only way to kill a negative is to have another negative. Then they'll kill each other, right? That's why if there's 3 negatives, like if I said negative 1 times negative 1 times negative 1, 2 of them kill each other, and then there's 1 left alive. That's why the answer is negative. So any odd number of negatives multiplying, the answer is going to be negative because there's always that odd man out that survives, hides behind the rock unless the other 2 kill each other.
If a negative number, if there's a negative coefficient to an exponent with an odd number, does that mean that that outcome is going to be like a different
All right,
the numbers
so
we were just talking about,
okay,
like a negative 6 to like
okay,
the
negative
third
6
power.
to the third,
Is it going to be a
like
negative
this, like this.
6? Yes, yes.
That answer will be negative.
Yeah. Oh, okay. So
Yeah,
are the
because there's
odd-
3 negatives. It'll be negative, whatever 6 times 6 times 6 is.
And
right?
if it was like 5, would it still be negative 2? Like if
Yeah,
they're all-
totally. If I have negative 5 cubed, or do you mean like negative 6 to the 5th?
Yeah.
Yeah, it's going to be a bigger ass number, but I know it's going to be negative.
Okay.
How do I know that? Because there's 5 negatives. Every pair of negatives kills each other. Pick the right one, Jeff. Every pair of negatives kills each other. There's one I definitely don't want to pick. Every pair of negatives. So the answer is going to be negative. Does that make sense? Negative 6 times negative 6 is positive, times negative 6 is negative, times negative 6 is positive, times negative 6 is negative. And then whatever the hell the big ass number is going to be, you're going to have 6 times 6 times 6 times 6 times 6, right? Is that? So, is this positive or negative?
Negative.
Negative. There's an odd number of negatives. So 106 of them are going to kill each other, and then you got that one left to make it negative. I really want to make so watch. What's negative 1 times negative 1?
1.
Positive 1. There's an even number of them. What's times negative 1?
Oh, negative.
It's an odd number. Times another negative 1. Positive. Even number. See, so if there's an even number of negatives, the answer is positive because they all kill each other. If it's an odd number, there's that one dude that escapes. Because they all pair up. We're dead. You know. And then one guy's over there like, yeah. So if there's an odd number of negatives multiplying, the answer will be negative. Do you see what I mean? It's not something to memorize, is it? If you realize why it makes sense, you didn't really memorize it. You just know it. You're just gonna do it. You don't have enough space in your brain to memorize everything. It's not a knock against you. It's a knock against humans. We don't have enough space in our brains to memorize everything. Not yet. A few more years, we'll have that little memory chip. Ooh. We'll do that Johnny Mnemonic shit for the Matrix. I want to know how to fly a helicopter. Okay. All right. Sorry. So continuing. Is everybody cool with this at the moment?
Yes.
So the 4x's, of course, kill each other. So I end up with 2 equals 10. No solution. I like it. So there wasn't as much weirdness there because the X's were all on the same side, so they killed each other in my face. They're like, oh, you're dead, Ocean. And then this one, of course, this one also should be. Oh, yes, sorry.
I got like the same answer even though I added the 6.
I love it. So you got 8 equals 16.
Yeah.
Yeah. So I could subtract 2 right now and get 0 equals 8. Right? Or I could have subtracted 10 and got, what would it be? 2 minus 10 is negative 8 equals 0. No matter how much you put on both, you're never going to make them equal. So it's always going to be no solution. So thank God. This is why I said the most important thing is get your variables together and see if they kill each other, because then you can just see what you got left. It doesn't matter how you move the numbers around. You're going to get the same answer. Yeah.
So I got 14, I don't know why, but because I added 8 plus 6.
Oh, no.
That would have been wrong, or?
Yeah, because, I'm a math teacher, so I'm an asshole. So I would take a point off or something, depending on how much the points were, just because it's not supposed to be minus 6. You got the right answer for the wrong reason. Right? And a lot of people don't get that, but like I try to stress, the answer to me is nice. I grade on process. If you don't realize that negative 2 should make that a negative 6, that's something I need to point out to you. That's a huge concept. I like it. So that's why would you lose points? You would have gotten the same answer. You would have said no solution, but you got there for the wrong reason. Yeah. When we get to word problems, I like to give an example of if you were in driver's ed. I remember my driver's ed, I loved it. My teacher was always a little drunk. He's not a lie either. You could just, ooh, okay. If you were in driver's ed and the final exam was to drive to the mall, and you proceed to walk to the mall, and you call, I made it to the mall. I did what you said. It's like, well, you didn't freaking drive. This is driver's ed. When we get to word problems, do not come up and say, I got the answer right. Why'd you say points off? You didn't use algebra. And what's in the title of the damn class? Algebra, right? So it's just like driving. If you get there by walking and it's driver's ed, you ain't going to get the points. So don't yell at me. I got the right answer. I know how much John made and how much Sally made. I'm like, but you didn't use algebra. That's what this class is. It's like you didn't drive the damn car, right? You guys, does that make sense? So just let go of that. The word problems very often are easy enough that you can see the answer so that you know what to expect when you do the work. You're like, I know the answer is supposed to be 2 and I got 7. Now I know I did something wrong. Let me see. Right? So that's kind of nice that we did that for you. Okay, maybe. All right, that's in our very near future. Very, very, very near future. This guy, real quick. 12x minus 6 equals negative 12 plus 12x. The 12x's cancel, right? So then the answer again is no solution. Okay. If you want to, you can put this symbol. If you want to put that symbol, that means the same thing. It means no answers. No is like, it's officially the empty set. So it's like, here's a bucket with all the answers. It's empty. There you go. Here's a bucket showing you all the F's. Like, it's empty. Okay, there. All right, one last section, then we'll call it a day. And then Monday, I think we'll devote to 2 things: word problems and percentage problems. Ooh, yay! We are on page 6. Page 6. Yeah, thanks, Jeff. I want to see what the number 6 looks like. Here's some stuff. These are nothing to necessarily memorize by now. In fact, to be really honest, I wish you didn't know any perimeter formulas. That's the stupidest thing to ever memorize. Because what's the perimeter? Add up on the side. I don't need a formula for that shit. Area, how much do you cover? Oh shit, I gotta know area formulas because I can't count that. I gotta multiply to get that. I'm like, what do I multiply? Is it half because it's a triangle, or is it a trapezoid? Oh shit. Trapezoids are, of course, beheaded triangles. So there's that 2 pi r thing we were talking about earlier. Right? So right now, this section is all about dealing with equations that have very few numbers in them and still solving. And people just really trip out. They're like, I didn't like that one stupid x, and now you got b's and h's and l's and w's and shit. So, Let me show you an example of the idea of this. Oh, I have a notes page. Sweet. So watch this. Let me write down here. Let's see. A plus BM equals W. Oh! Sorry about that. I have no idea why I made that sound. Now, can somebody tell me how these two are really the same thing? 7 plus 5M equals what, Jeff? I don't know. 2. Do you guys see how those are the same equation functionally? I mean, if I let A be 7 and B be 5 and W be 2, those are the same. So the steps you would use to solve that equation for M is the same steps you would use to solve this equation for M. How do you know it's M you're solving for? I'd have to tell you. So that's my bad. Solve for M. There you go, Jeff. Get M by itself. What would be the first step on this to get M by itself? Because here's where my M's are. Let me get rid of the other shit, right? So that subtracts 7. So what's the first step over here to get M by itself? Subtract A. Do you see what I'm saying? So if you know how to solve equations, you know how to solve any equation, even if they have no freaking numbers in them at all. Who cares? The process doesn't care. We care a little bit because we're humans, but we should go, okay, I shouldn't care. In fact, the funny thing is somebody pointed out, when you have no numbers, you don't actually have to do anything. You don't have to combine anything. So remind me, what did you guys just say? What do? Subtract A. What is W minus A? W minus A. See what I mean? You got less to do, just right. What's W minus A? It's W minus A. There you go. Right? It doesn't equal pineapple. I don't know what this shit W minus A is. It equals fuchsia. No, it's just W minus A. So over here, of course, I can do 2 minus 7. And what's the last step? Divide by the thing I don't want, the coefficient, right? So divide by 5 there. Over here, I would divide by B. Now, I think a part of your brain should probably feel unsatisfied with this. But they're letters. I can't combine them. The reason we have to have this skill is because this might be a more useful form than this. What if I knew a bunch of A's, B's, and W's and I had to solve for M? Do I want to solve for M every single damn time, or do